Hello, today we'll discuss about the transistor. So there are two basic types of transistors. There are two basic types of transistor. First is the bipolar junction transistor. And second is the feed effect transistor. There are two types of the transistor, the bipolar junction transistor. It is also called as the BJT and the feed effect transistors. We'll discuss about the bipolar junction transistor. So this is the bipolar junction transistor, and it is a combination of the two junction diode. This is one junction and this is another junction, consisting of thin layer of the p-type semiconductor. Okay, so this is a two junction diodes consisting of the very thin layer of the p-type semiconductor material, which is sandwiched between N1 and N2. That means it is sandwiched between two N-type semiconductors, and this is referred as the NPN transistor. Okay, or a thin layer of the N-type, you may also describe, if here it is a thin layer of the N-type, which is a sandwich between two p-type material, then that is called as the PNP transistor. Okay, so this is the junction diode, which is formed by the N1P. This is one junction. Another junction is formed by the PN2. So this is biased in the forward direction. This junction P1, N1P, it is a forward bias. Is biased in the forward bias by the battery B1. Okay, and so the free electrons are moving from N to the base, and some of the electron they move toward the N2. So this is the battery B1. This is the battery B2. So here N1 is termed as a emitter. This is termed as emitter, and this is a base is common to both emitter and collector. Therefore, this is a common base is there, and this is a collector. So, if suppose the NPN transistor is there, this is a metal and very thin layer of N, which is a sandwich between P1 and P2. In this case, the battery is connected like this. This is a B1 and this is a B2, and this is a base current, and as the current is flowing like this, so this is a emitter current and this is a collector current. So this is for the arrangement of bipolar junction transistor for the NPN transistor. This is PNP transistor and this is for NPN transistor. Okay, so if you consider here the some electrons is passing through the base from this, some electrons is passing through the base combined with the holes, other reach to the base terminals and some will reach to the collector. Electrons which do not reach to the collector end 2, that electrons are responsible for the current at the base terminals. Therefore, distribution of electron flows in the NPN transistor can be represented like this. And therefore, the conventional direction of the current are, what are the conventional direction of the current? Conventional direction of current represented by, this is a conventional direction of the current. It is outward. This is a coming into the circuit. This is also coming into the circuit. So these are the conventional direction of the current for the NPN transistor. And this again can be shown in detail like this. Suppose it is a PNP transistor. So this is emitter, this is base, and this is collector. Base current and this is emitter current. So conventional direction of the current, by making the thickness of base very small, more current can flow toward the collector current. So here suppose the emitter current is suppose 1 milliampere, and therefore very small current will flow through the base and more current will flow. So as emitter current is the combination of base current plus collector current. So by the Kirchhoff's law, we can write here emitter current is equal to base current plus collector current. So if emitter current is 1 milliampere and base current is suppose 0.98 milliampere, and the base current is this. So total again we'll get 0.98 milliampere plus 0.02 milliampere. So this is 1 milliampere emitter current. Therefore, the common base circuits we have shown like this. This base is common, therefore this is a emitter and this is a collector. And this is for this is a base. This is a common base circuit because her base is common to both emitter and collector. Here it is a emitter, this is a collector and this is a base. So this is for NPN transistor and this is a common base circuit for PNP transistor. Okay, in this way we can draw the circuit. Similarly, if the emitter is common, we have the certain other types of the circuit. Common emitter circuit. If it is a common emitter circuit, that means emitter is common. This is suppose emitter, and this is now collector. And this is a base. Okay, therefore we can show battery like this. Here emitter is common. This is a collector. This is a emitter current. The collector current is, this is collector and this is base. Collector current will flow. So this is a common emitter circuit because here emitter is common to both base and for NPN transistor. And now we'll draw the same common emitter circuit for PNP transistor. PNP means it is like this. This is emitter and this is a collector. So this is a emitter, this is a collector and this is a base. So this is a common emitter circuit for for PNP transistor. This is a PNP transistor. Okay, now we'll discuss the input output characteristics. Input output characteristics for a common base circuit. So for common base circuit, we have base is common. So this is common. This is emitter. This is collector. And here we have to measure the current. Therefore, this is one ammeter. Ammeter A1, we can call this ammeter A1. And we have to connect the battery. So this is the battery plus minus as the current is flowing in this direction. So here it is a negative terminal like this. So this is a rheostat and this terminal is connected here. Okay, we have to also measure the voltage, therefore this is a voltmeter to measure the voltage, and this is connected to this base circuit. So this is negative terminal, this is a positive terminal. This is battery B1 suppose. Here also we have to measure the current, therefore we will connect one ammeter here in series. We have to also measure the voltage here, so we will connect voltmeter V2, and again we have to also keep this current or vary this current, and that can be varied by connecting it to the rheostat. Rheostat will be like this, and here the battery, here B2 positive, negative terminal, this is battery V2. So this is the circuit diagram for the input output characteristics for the common base circuits, or it is also called as the static characteristics. So, and this is the NPN transistor. So NPN transistor used in a common base circuit, the procedure is to maintain the value of emitter current. We have to maintain the value of this emitter current, and how we can maintain this? Even there is slight changes in this current, we can vary this rheostat, and we can keep this current constant. And now by varying this potentiometer, suppose this is R2 and this is R1. By varying the resistance of this potentiometer, we can vary this current, and similarly the voltage will also vary accordingly if you vary this rheostat. So we have to maintain this current, emitter current constant, and measure the current flowing through the collector and the voltage across the collector base, take the reading, and we have to plot the graph. So here the current is assumed to be positive when the direction is from external circuit toward the transistor terminals. But here the current is going from the transistor to the outward side. It means that we have to take the sign of the emitter current is negative. Okay. Therefore, and the voltage VCB is positive. Here voltage VCB is positive. That is voltage across collector and base is positive. When C is positive with respect to the B. Now it is positive with respect to the B. So it is a positive, but emitter current is negative. Okay, here emitter current is negative, but this voltage is positive here. For NPN transistor, if suppose this is NPN transistor, but for PNP transistor, all the signs have is to be reverse. We have to, if the NPN transistor is used, all the signs we have to reverse, means emitter current will become positive in that case. So now we have to keep this emitter current constant. By keeping the emitter current constant, how we can constant? Even it varies, we have to just vary this rheostat and measure this collector current and the collector to base voltage. And if you calculate these characteristics, it will be the collector current on this side and on this it is a collector to base voltage VCB. On the x-axis it is a collector to base voltage, and on the y-axis it is a collector current. So for given emitter current, so this emitter current is negative. Suppose we'll keep this for 1 milliampere, so we'll get the characteristic like this. This is for emitter current when it is a minus 1 milliampere. So we have kept here 1 milliampere current constant. Now set again reading for 2 milliampere constant and vary this rheostat and measure this VCB and the collector current. Will get the reading like this. And this is for when emitter current is suppose minus 2 milliampere. Again change this to the certain value minus 3. Where to this is a emitter current when it is a minus 3 milliampere. This is again for the minus 4 milliampere. So by keeping any value constant for the emitter current, we can vary this rheostat and measure the collector current, which is measured by this A2, and measure the voltage to voltage between collector to base terminals. And if you plot the characteristics, we'll get this such type of the characteristics. So here we can see that for positive value of the collector base voltage, collector current remains almost constant. For positive value of the collector base voltage, the collector current almost remains constant. We can see here it is a almost remains constant for positive value of the collector to base voltage. Okay. So for given collector current proportional it is practically proportional to the emitter current. So we have also got the reading of collector current and emitter current. So on this side it is a collector current, on this side it is a emitter current. Because emitter current is negative, so we have taken the reading for 1 milliampere. We have also taken minus 2, minus 3, minus 4 milliampere. This emitter current in milliampere and collector current is also in milliampere. So 1, 2, 3, 4, and if you plot this reading, we got the linear characteristics. So the current collector current varies practically proportional to the emitter current. Collector current is practically proportional to the emitter current. So for these values, we can calculate the change in the collector current for this value to this change in the emitter current, and therefore the ratio of the change in collector current, this value, to the change in the emitter current for a given collector base voltage is termed as the current amplification factor, and it is denoted by alpha. Current amplification factor alpha. This is for given value of VCB. So this alpha is equal to del IC by del IE. Here the slope is negative. So this is all about the input and output characteristics. This is called as the input characteristic because this is related to the collector current and emitter current, and this is the collector to collector base voltage. Then this is also known as the static characteristics for the common base circuits.